Hello, my name is Nikita Lipsky, and today we will talk about Jigsaw Layers. When I was at Java 1 last year, I visited quite a lot of sessions about Jigsaw from creators of Jigsaw. Mark Reinald, Alex Buckley, and almost any session was ending with a question. Why Jigsaw does not have versions? When Jigsaw will have versions? Or how can we live without versions? There was no clear answer on these questions. Honestly speaking, it is not easy to give an answer to the questions on a questions and answers slot of a session. So I decided to give a detailed answer why Jigsaw does not have versions and what it has instead. But who am I? For nearly 2 decades, I have been working on Excelsior Jet project, which is complete JavaC implementation, JVM, with a head-of-time compiler. Using our head-of-time compiler, you can compile your Java or JVM applications down to conventional native executables. And unlike some other AUT solutions, Excelsior Jet supports all Java features. So yes, reflection, dynamic class loading just works. You don't need to do any hacks to make it work. And you can compile Tomcat, Spring Boot applications with Excelsior Jet without any problems. And I worked on this project from the day one and contributed to all its components. For instance, I authored OSGi support at the JVM level, Java runtime slim down technology, that is JavaC componentization split of JavaC into modules that was available to Excelsior Jet users from 2007, 10 years before Jigsaw release. Also, and I do many other things. Recently, I have added Spring Boot support to Excelsior Jet. You can find me on Twitter, and Excelsior Jet has a team blog where we publish various technical articles about development of our not so usual JVM. So what we are going to talk to today. First, the disclaimer. It is not a Jigsaw introduction or overview session. So I expect from you that you already know some Jigsaw basics. You can find quite a lot of introductory sessions on the YouTube. But anyway, I will give you some basic, very short introduction to Jigsaw that will be enough for you to understand the content of this talk. And with this basic information, we can pose jar hell problem, and we will talk then about versioning and problems regarding versioning. By the way, maybe someone saw my last year talk about OSGi versus Jigsaw. Wow, great. So disclaimer for you, I took the versioning part from that talk. So you might think that you have already seen this talk, but don't be afraid. There will be, I will talk about Jigsaw Layers as well, and how they help solving jar hell problem. In the end, there will be a live demo and some bonus track. So let's start. So any module system is all about import and export. A module imports something and exports something. Extremely easy concept, easy as apple pie. And the module in GPMS is described with a source file called module-info.java in the root of your source directory. So modules become, what's going on? So modules become a part of your source code and not some external metadata. And modules imports other modules with requires keyword, and they exports packages with exports keyword, and they also can import and export services with uses and provides keyword. And once import and export is resolved, modules form a so-called dependency graph. And that's all that I wanted to give you as introductory to Jigsaw. Really, Jigsaw modules are very simple concept. It's import, export, dependency graph, and we are done. But anyway, even with this basic information, we can now pose the problems that we will fight during the session. It's the jar hell problem. The jar hell problem is most easily illustrated by the following example. Let's suppose the app depends on a library foo. At the same time, it depends on a library foo depends on a library bus of some version. And at the same time, your app depends on a library bar that also depends on a library bus, but of a different version. And if you put both versions on the class path, it becomes unclear which version would actually get loaded and whether your app would behave correctly after that. Most probably one version would partially overwrite another one, leading to unpredictable program behavior. So to solve this problem, Jigsaw module might have a version in early Jigsaw drafts. Thus, import-export could be qualified by a version, and if two modules require two different versions of one library, both versions could be loaded. However, versioning was removed later. You may ask why. So let's discuss it. First, let's think how to implement versioning. So we have a problem. For a given module A, importing library lib of version v1, and module B, importing library lib but of version v2, it is required that both versions of lib work without conflicts. And to solve this problem, Java had class loaders feature from the day one. So class loaders provide unique namespaces, so a single JVM can load two classes with the same fully qualified name, provided that they are both loaded by separate class loaders. Thus, if each module is loaded by its own class loader, the classes of one module won't conflict with classes of other modules. And thus, the case when two versions of the same library are loaded by Jigsaw becomes resolved. So we have quite a clear problem and a quite clear solution. So why don't just implement it? Let's discuss this. So we just understood that, that if we would like to solve a versioning problem, we come to the idea that each module should be loaded by its own class loader. And it was exactly so in the first Jigsaw drafts. However, let's remember that Jigsaw is not just modules, but also Java SE platform split into modules. By the way, Jigsaw had been developed for 10 years, not without reasons. One of the main reasons was that it was really hard to split that monolithic RT-jar into well-defined modules with well-defined dependencies between them without cycles, access, and so on. Fortunately, this job was done, but JDK developers faced with certain problems regarding the split of Java SE platform and versioning. For instance, according to the Java specification, all core platform classes should be loaded by so-called bootstrap class loader. It is internal JVM class loader that has no instance. So get class loader should return null for platform classes. And it efficiently precludes splitting of Java SE platform into modules where each module is loaded by its own class loader. You would love, but the fact that some misconcept could be unavailable in Java 9 is not backward compatibility issue from JDK point of view, because Java specification never claimed you that you will have that class. But it claimed that get class loader should return null for platform classes. So changing that behavior would violate Java's specification, backward compatibility directly. Backward compatibility is still holy cow for Java. JDK developers work really hard to keep the invariant that everything that was guaranteed by previous version of Java satisfied for a new version of Java. That's why if you have a Java application that works for some older version of Java, it should work on a newer version of Java without any changes, if, of course, your application does not have some reliance on unspecified behavior of unspecified behavior. Many class loaders for an application may also cause problems for your own applications. For instance, your application may have some your own class loaders, and that class loader most probably had a system class loader as a parent class loader. And if we have modules that are loaded by separate class loaders, what should you specify as a parent for your own class loader? And even the fact that application class loader does not extend URL class loader anymore causes problems. Not so long ago, a creator of async profiler, Andrei Pangin, tweeted, "Ironically, even official Java 8 demo from Oracle, Java 2 demo, does not work on JDK 11. And it's because some Java 2 demo class tried to cast application class loader to URL class loader." By the way, it is not backward compatibility problem from JDK point of view again, because Java specification never claimed that application class loader extends URL class loader. So it is a problem of Java 2 demo application, not of JDK. It is classic example of reliance of an Java application on unspecified behavior. But anyway, you may have similar problems when you switch to Java 9+. Now let's think if versioning really solves the jar hell problem. So here is our favorite picture of the jar class path hell that we would like to solve with versioning. So what does the fact that an app requires a module foo? The app requires two different versions of the same library. It means that if first version of Buzz has a class A, and then the second version may also have class A, but different class A. And what does the fact that module foo imports module bus mean? It means that it can use any of classes of bus, so it can use our first class A. And the same holds for the second class A. And what does mean that app requires module foo? It means that it can use any of classes of foo that in turn may use that first class A. And thus, class A appears in the namespace of our app module. And the same holds for the second class A. And now we can watch the following dialogue between them. First class says, "I'm A." Another replies, "No, I'm A." And everything blows up, of course. It can be demonstrated by the following. So what I would like to say, the JVM specification defines so-called loading constraints that prohibit two classes with the same fully qualified name to appear in the namespace of another class. And for instance, in this example, if the class B is loaded by L1 class loader and class A is loaded by L2 class loader, maybe it's better to show here. And then JVM will check that T1 is the same for both class loaders. And if it is not the case, JVM throws Java linkage error. And the problem is not rare. Everyone who plays with class loaders faces with the problem sooner or later when two different classes with the same name starts meeting. So we can conclude that versioning does not really solve the jar help problem, but raises it to a new, more sophisticated level instead. And there is one more detail. Import in early Jigsaw versions was qualified but by not a single version, but a version range. So a module may declare that it can work with dependencies from version to 2 version. By the way, I have found how versions could have been described in early Jigsaw drafts. Here, for instance, module, my module of version 1.0 requires lib.module of versions from 1.1231 to 4.0. Little bit weird syntax, isn't it? So a prototype was written on all of this, and JCK tests were written. And I remember very well how Alexei Shepilov told me that once a JCK tester wrote a test that passed half an hour on quite powerful Oracle workstations. And when JDK team starts to resolve that issue, it turned out that resolving dependencies from version ranges is an P-complete problem. It's simply reduced to 3 set. And after that, versioning in JPMS breathed its last. Jigsaw architects could not allow to introduce in Java standard something that could lead to potentially infinite startup time, of course. And if there is no versioning, there is no need for class loaders for modules. And if there is no class loaders for modules, we don't have class loader constraints violation problem, and no backward compatibility issues because the set of standard class loaders remains the same as it was in Java 8, and the resolver becomes much, much easier. So all problems were solved, except the original one. So how to solve the jar hell problem now? First, this situation is simply prohibited by Jigsaw. 2 different versions of one module just won't get into JPMS, which is good because you recognize the problem right on the application startup and not at runtime at unpredictable point, causing you to waste a lot of time in debuggers. But you may ask, wait, Jigsaw does not have versions. How can it detect this situation? And here we can note that the most probably 2 different versions of the same library have same packages. And Jigsaw prohibits for 2 modules to have same packages that are called split packages. OK, that's great that Jigsaw can detect this conflicting situation, but how to solve jar hell, after all? And now let's remember about backward compatibility again. So Java, as a platform, has a backward compatibility feature, and it is natural to expect that libraries that are written in Java also follow backward compatibility rule. So it sounds reasonable to resolve the situation by choosing the newest version of a conflicting library. But unfortunately, libraries are not backward compatible, are not always backward compatible in reality. So it might happen that library foo does not work with a newer version of library buzz. Thus, you can find a newer version of library foo that works with a newer version of library buzz. And playing with the dependencies such a way, you'd probably find a suitable configuration that works. However, you have a really big application where dependency graph looks like on this picture. Playing with the dependencies may not work that good. Remember, dependency resolution problem is NP-complete. And trying to solve this problem manually can make you really sad. So to solve this problem, developers invented another way that works even on ClassPath. The way is to just relocate classes of 2 versions of a library to different Java packages. And you can do it automatically using Maven Shape plugin, for instance. However, this solution may not work again because Java has a reflection, and reflection is not always loyal to class relocations. So there is one more solution, of course, to use class loaders. So if you move conflicting versions to different class loaders, you can, of course, solve this problem. You can write such class loaders by yourself, or use a framework from small one on to big ones that will do it for you. However, I don't suggest you to overuse this approach, because else you will need to fight with the class loaders constraints violation problem. And even a framework that you choose addresses this problem somehow, you will have hard time of refactoring your dependencies once different classes with the same name start meeting. And here we come to the culmination of the session. I will talk about Jigsaw layers now. So yes, the first solution is to use Jigsaw layers. So what is Jigsaw layer? A layer in GPMS is essentially a local module system. When I told you that split packages are prohibited in Jigsaw, I was a bit incorrect. They are prohibited only in one layer. But if two modules with the same packages belong to different layers, then Jigsaw does not treat it as a conflicting situation. Jigsaw itself defines so-called boot layer that contains platform modules that are loaded by bootstrap loader, platform extension modules that are loaded by platform loader, and your application modules are loaded by application loader. At any point in your application, you can create your own layers, and split packages are prohibited within one layer, but different packages, one package with different packages with same name can belong to different layers. So here you can see Hadoop layer and JavaScript layer having different versions of Guava and Jackson. So if we see now different versions of the same library, it becomes interesting. How layers are implemented from the inside. And of course, they are implemented via class loaders. So each layer has at least one unique class loader, may have several ones, like a boot layer. And now you can exclaim, wait, so what about class loader constraints? Won't we have exactly the same problems that we could have with versions? And actually not. Because class loaders constraints are impossible to violate by construction of Jigsaw layers. Let's understand why. So here's our favorite picture with jar hell. And Jigsaw suggests to resolve it by moving your application modules to a separate layer. The most probably it will be boot layer. And libraries of conflicting library are moved to separate layers as well. And this way, we solve our problem. But I feel that it is not everything okay with this picture. Let's play a game. What differs in these pictures, except that we now see big green boxes around small ones? Who can tell me?
It's vertical.
Huh?
It's vertical, the direction of
Yes. The direction of arrows, right? An arrow direction from A to B means that A imports B. So app imported foo before the, and now foo imports app. That's it. What does it mean? Actually, every layer has a parent layer. And the modules of a child layer can import modules of parent layers without problems. However, parent layers modules cannot import child layers modules. And that's why it's impossible to violate class loader constraints. Let's remember how we got the class loader constraints problem. So we had two different classes that were able to move via dependencies from the downside up and meet in the app. But now arrows goes in opposite direction. So these two versions of class A have no chance to meet. And now we can hear a completely different dialogue between them.
There's a space between us, a place that I can't go.
Who knows Carole King here? No? Maybe you know, oh, Carol, I'm but a fool. Baby, I love you of Neil Sedaka. No? It's old songs, right. Okay, let's go further. So looking at this picture one more time, we can come to a question. If application modules cannot import child modules, then how they can employ functionality implemented in these child layers? And this we can be rescued by the well-known pattern called inversion of control. Who knows inversion of control pattern here? Yes. Who doesn't know? Okay. No, everyone knows. That's great. The idea of inversion of control pattern is as follows. So if you need some function, if we need to implement some functionality using some other functionality, then instead of importing that functionality, we declare an interface saying that I need some functionality by this interface, and someone outside implements that interface and injects that dependency into your class. It can be done manually by passing interface implementation instance to constructor of your class, or it can be done automatically using dependency injection frameworks such as Spring or Juice. And inversion of control pattern works in Jigsaw as well with a native Jigsaw mechanism called services. Yes, modules of parent layers can't import modules of child layers. However, modules of child layers can provide services to parent layers. Let's look at our picture again. Here we see that library foo imports module app. It's nonsense, of course. Library modules can't import our application modules. And to fix this picture, we need to add a bit of code of our own application that from one hand will import our modules, and on the other hand will provide services to our application modules. And it is the right picture that really solves the jar hell problem. So here, theoretical part of my session is coming to end. So now let's talk about practical aspects of the subject. How can we use layers within our applications? Today, layers are created unfortunately, by a programming code. That code is very declarative, so one can imagine a framework that would create layers for using some external metadata. But I'm not aware of such frameworks so far. By the way, it's a good idea for open source project. So now we need to create layers manually. And to do that, first we need to tell Jigsaw where our modules located. And it is done by creating so-called module finder object. Then we need a parent layer. In the most cases, it will be the boot layer. And then we need to resolve modules within our new layer, resolve dependencies within our new layer. And it is done by creating a configuration where we pass our finder and the root of set of root modules names to start resolve dependencies with. And if we succeeded with creating configuration, we can create a module layer with the parent layer, and just created a configuration and the parent class loaders that will be used for creation our layer class loader. And once we have created a layer, we can use it for service loader that will load services that are provided by the layer. And now it's live demo time. Oh, OK. I have created a simple application that collects Java conferences around the world. But it collects them not by its own, but using Java conferences provider services. And that are described by the following interface. It's very simple. It just provides a string. And here we get all services that we have, all implementations of our Java Conf provider interface, and just output everything that services provide on the standard output. The module declaration of this module looks very similar or simple. We just export our Java Conf provider interface and use all its implementations. And if we run our example now, so what's going on? Yes, if we run our example now, we don't get anything because we have no Java Conf providers. So let's add some. Let's add Devoxx Belgium provider. So it is Devoxx Belgium provider module declaration. It has a name Devoxx Belgium provider, and it provides service with the following implementation, which just returns hello from Devoxx Belgium. And if we run our example now, we don't get anything again because our Java Conf collector module doesn't know anything about newly created Devoxx provider, Devoxx Belgium provider module. So we need to add Devoxx Belgium provider to the module path of our application. And to add it, the most easily it can be done here. We just use Devoxx Belgium provider as a class path, but actually it configures module path. And if we run our example now, yes, it prints hello from Devoxx Belgium. But let's add another module, another conference provider called Devoxx Ukraine provider. Its module declaration looks very similar to Devoxx Belgium provider. It also provides Java Conf provider interface, but in the same package that Devoxx Belgium com.devoxx, but the implementation differs. It returns now hello from Devoxx Ukraine. And if we run our application now, we also we won't get anything new again because neither Devoxx Belgium provider nor Java Conf provider know about Devoxx Ukraine provider. So we need to add Devoxx Ukraine provider to the module path, and here we have certain problems in IDEA because IDEA requires a single root module for configuring module path. But now we have two roots, and to solve this problem, I found the only workaround. It is to add Devoxx Ukraine to the dependencies of Devoxx Belgium. And now we have the single root. And if we now run the example, the application fails because package.com.devoxx is within both modules, Devoxx Ukraine provider and Devoxx Belgium provider. So we have just simulated our jar help problem. These modules look very similar, and Jigsaw was able to detect this conflicting situation. So now we need to resolve this problem. And we will resolve it by moving Devoxx Ukraine provider to a separate layer. But first we need to remove Devoxx Ukraine provider from the dependencies of Devoxx Belgium provider. And let us. So now we will create a separate layer with the code that I have just shown you on slides. And we use first parameter for location of our module, and we have a name devoxx.ukraine provider. And after creating the layer, we can use it for service loader that should return services from just created layer, and also all services that are declared in a parent layer. We have Devoxx Belgium layer in the boot layer, so now we should have both services. And if we run our example now, drum rolls. Yes, we see both providers now. So we had a problem, and we just solved it with the layers. And so, great, we can continue. Huh? I have prepared it before in the run configuration. Sorry, I didn't mention it. I passed just location of Devoxx Ukraine provider to the runner into run configuration for Devoxx Ukraine provider. So it was able to find it and create a layer. So you have just seen a simple console application, but today Java is used mostly on the server side. However, on the server side, we have a problem that application servers aren't aware of modules. So if you develop a server-side application that you deploy to Tomcat, for instance, you just cannot tell Tomcat where are your modules. What does it mean? It means that you cannot benefit from Jigsaw somehow on the server side. Who saw my last year's session about Jigsaw versus OSGi? No, the Jigsaw has a mantra. And the mantra is reliable configuration, strong encapsulation. So what does reliable configuration mean? It means that Jigsaw guarantees that no required modules are missed in your final configuration. There are no cycles in the dependency graph, and there are no split packages, meaning that you don't have two versions of the same library in the final configuration. And reliable configuration means that that everything that is not exported by a module can be accessed even via reflection. So you are free to change your implementation details without being not afraid that someone relied on that implementation. But unfortunately, this mantra does not work on the server side. And I thought that we should not put up with it. Actually, all these modern web application servers are open source. So we can fork our favorite application server, adding a modular layer to its class loading logic. And I did it for Tomcat, and I would like to share you with the results. So first, let's understand how class loading works in Tomcat. So in the class part of Tomcat, there is a jar called bootstrap jar that creates a class loader that loads all other jars of Tomcat. And every web application is loaded by its own class loader as well. And since Java 9, a class loader can assign a module for a class it loads. But if it does not do that, all its loaded classes will belong to so-called unnamed module, even if classes of that module formally belong to a named module. It has, for instance, it has module minus info.class declaration in the jar. And it can be demonstrated by the following example. I created a classic modular hello world example that contains two modules. One provides a string hello world, and another outputs the string on a web page. But it also outputs module names of loaded classes of that two modules. And if we run our example on a usual Tomcat, we will see that modules have no name. So they belong to unnamed module. However, if we run the example on my fork, we see the names. And I'm going to tell you how I achieved this. So first I had to tweak class loading logic of Tomcat itself. Before my patch, Tomcat was loaded by a simple URL class loader. I created a modular layer with Tomcat jars, with the code that is very similar that I have just shown to you. And then, class loader, yes. And then I had to tweak class loading logic of web applications class loader. Tomcat loads classes of web applications from two places, webinf/classes and webinf/lib of a WAR file. I left those two places intact and introduced third place that I named web-inf/modules, and here I create a layer with jars from webinf/modules with a very similar code, but with the difference that now we use, as a parent layer, we use a layer with Tomcat jars. So our layers hierarchy becomes 3. And it is important because every web application uses, for instance, servlet API. Servlet API jar is within Tomcat jars, and in order for your web application modules to be able to resolve to service API jar, we need to provide Tomcat jars layers as a parent layer of our web application layer. And then I use that layer to load web application classes. And after that, I've got the module and their names at runtime. So I achieved Jigsaw enlightenment. However, you may say that Tomcat is yesterday. All we have Spring Boot, microservices today. One might say that modules are not needed in microservices world. It is debatable question. We can discuss it later. However, may you have any problems with Spring Boot if you would like to use it with Jigsaw? And the answer is yes, because if you deploy your Spring Boot application as an executable jar, then your application classes will be loaded by Spring Boot application class loader. That, of course, knows nothing about Jigsaw. And hence, there are no modules at runtime for Spring Boot applications deployed as Spring Boot executable jars. However, actually, you can launch your Spring Boot applications without Spring Boot loader, putting all your dependencies or external dependencies just on class path. And hence, you can use standard migration path for modules. That is, you move all your jars from class path to module path, and then you add a modular declaration for your own modules. However, please note that if you follow that way, you have to deploy your application not as a single jar, but as a bunch of jars. And if you absolutely require one jar deployment, you can fork Spring Boot class loader and adding a module layer to its class loading logic. Spring Boot is open source. It has the only class loader, so the task seems to be 2 times easier than I solved for Tomcat. And that's all for today. Let's sum up what we've learned. So in the beginning, we talked about versioning. And versioning for modules look like a good idea, but there are many problems with them. So we have certain problems with backward compatibility, and it's hard to use versioning safely because of class loader constraints. And NP completeness on dependencies resolution is just a showstopper for them to appear in Java standard. On the other hand, Jigsaw layers allow you to solve the jar health safely because class loaders constraints are impossible to violate by construction of Jigsaw layers. And using Jigsaw services, you can use functionality implemented in a child layer from a parent layer. And knowledge about the layers can help you in modularizing of your Java application, including the server-side applications. Yeah, I was fast. Questions? Can someone give microphone?
Thank you for your talk. Can you please show the slide with inversion of control?
What slide?
With inversion of control, with inverting dependencies. In this way, you are trying, or Jigsaw is trying to solve the problem of duplicating a class, which is migrating from transitive dependencies. But inversion of control only solves compile time dependency problem. But at runtime, it takes all the dependencies into the application. So you can access both A classes with the same name. So how it really solves the problem?
Okay, that's a great question. Of course, if you, at runtime, objects can move in any direction, so different objects with the same, which has a class, two different classes with the same fully qualified name can meet. But actually, if you follow this architecture, the chance that they will meet actually becomes very rare, because how actually they can move from this, an object can move from this place to this place. You should get some object from this layer, but it won't be, it won't have a type, a particular type, yes, and then you should pass object that you get from this layer to this layer, and this layer should cast it to get your problem, right? But I think if you follow this way, you hardly have this problem, because it's just strange that your application will behave such a way. You should not pass objects from this layer to this layer, from my point of view. If you have a right architecture for your that this layer would treat as their own objects. It's strange, because they should use public interfaces, but not casting.
Yeah, they may use the same interface, but they may pass both instances of classes A from both modules under the same public interface. And that's how you could get two different classes with same names in the application.
Sorry, maybe I don't get totally.
If service provider 1 brings class A to application under some public interface,
yes.
and provider 2 does the same under same interface and same class.
It is not a problem, because now we have the only type that it is interface that doesn't lead to any problems.
Yeah, it's compile time, but at runtime, it's two instances of different classes with the same name.
But it's not a problem, because if you don't use it as instance of a concrete class, you won't have any problems at runtime as well. Because JVM doesn't differentiate. There is no problem for it to work with objects of different classes with the same name. It's not a problem. A problem is with the linking, when different classes with the name start meeting by signatures provided by different modules. If we have that problem, your application won't be just linked at runtime.
Yeah, thank you.
They are just different classes. And the problem only occurs when classes meet, and not objects. Maybe some other questions?
Yeah, so using service provider API seems to solve the issue with dependencies, with versioning. But how would you solve this issue if you have, if all your, some of your dependencies, basically, how would you solve this issue for transitive dependencies, where you cannot modify third party, right? So using this approach, you would have to make changes in source code in order to make use of service provider
No,
API.
you don't need to. You should refactor your application, and of course, because now you should add some app service provider module to the layer. That is your own code. But you don't need to modify libraries, external libraries, actually. You just need to wrap them with some your business logic, with interface of your business logic.
Yeah, but yet it still assumes that third-party libraries provides some services via service provider.
They don't need to provide any services. You just wrap them with your application modules that provide services to upper layers.
Yeah, so we need to implement wrappers, right?
Yes,
yeah.
You need to implement your wrappers. It's the only case when you can solve this problem, actually.
Okay, thank you.
Some other questions?
My question is about real world. I mean, what is happening with our RAM memory at the real applications when we have 2 or 5 or more separate class loader which load the same classes, which in Java it's not a little amount of the resources. So what is happening with the application when we have triple or more loading of the same classes?
Of course, loading several versions of the same library is not good. So if you face with this conflicting situation and you can actually solve it by choosing the only version, you should follow this way because it's the most easier way, and it is most economical way because no class duplication at runtime will be. But if you can't solve this problem, then Jigsaw Layers can help you to locate your problem to a particular layer. And of course, you will have some duplication, and it's bad, but you can solve their problem. Any other questions?
My question is, so Jigsaw Layers introduced for solving this jar hair problem only, or do they have some, should we use layers for application design?
Is it too different?
Is it designed for usage not only solve this jar hair problem?
It is actually they was designed for solving application service problem because all they use custom class loading, and to make them modular, the layers was the only way to solve application class loaders problem if we don't have versions. But unfortunately, application service providers, applications implementers don't use layers so far, but it was workaround for that problem. But of course, you can use layers for your own application because you will have clear separation of your application business logic inside your application. Actually, layers can be thought as microservices, but that lives in your under the only JVM. And actually, if you separate your application into layers, it can be very easy then to separate it to microservice as well. So you will have a choice to either to allow this concrete part of a business logic to live in one JVM or in separate JVMs.
So, and another question, if we use layers, as you said, for microservices, so-called, then is it possible to share some common libraries between layers?
Well, yes, of course. If yes, that's a problem, by the way, because if you will use all libraries that you use inside a layer, you put libraries in the upper layer and import them. So you can share, of course, them. But if you face that that the same library have two versions, you can move it to your own layer. So you have this choice.
Thank you.
Yes, yes, because also, by the way, services can also have not only one parent, but several parents. It can also help in some situations. Any other questions? So thank you for your attention. Great audience. Very good questions.